Okay, G. So vectors P3 mathematics lecture number 1. Now, vector is a topic that you have already covered in your O levels, but you could always have recap of O level mathematics. There are lectures in O level mathematics for vectors as well. But continuing with vectors that is being tested in P3. So normally there are two dimensional vectors in O levels, but when we work upon A levels, we'll work upon three-dimensional vectors that are X, Y, and Z. So knowing the fact that we have X-axis and the Y-axis. So this is your X, knowing the fact that this is your Y. So this is all 90 degree, 90 degree, right? 90 degree and 90 degree. But when we talk about X, Y, and Z, so that means we are particularly talking about the another axis that is here, which means just like a corner of wall. The corner of wall has three different axes, one going top, the other going on the right and the left. So this will become your Z. Now, if you understand that this will be 90 degree, in short, knowing the fact that this should be an other continuation of what? An angle, right? And this will be an angle as well. Now, you have what? Three different particular angles working on the x-axis, y-axis, and z-axis. So when we are working upon the angle, so that means this particular will be the cross-dimensional 90 degree. This is not the axis 90 degree. This is cross-dimensional 90 degree when we are talking about the wall. A wall figure is normally like this. This is your height. This is the wall width and the length. So there would be 390 degrees in this. Whenever you see at the corner of the wall, you look into it, the base corner, you look into the three different angles that are based upon the 90 degree. Now, if I just say that, let's just say this is your point A. Now, this point will have 3 points. Let's say 2, 4, and -8. And let's just work upon B. So B is -2, -8, and 16. So generally, the first one is representing X, the second one is representing Y, and the third one is representing Z. So clearing the fact that, let's just say that if A is 2, 4, and -8. So this is X, Y, and Z. B is -2, -8, and 16. So this is X, Y, and Z for the coordinate. Let's just work upon position vector so that we can continue with A and B. So what is position vector? Whenever a point is defined by its origin, it is known as position vector of that point. In O levels, generally what you did was, let's say that we had, this is your x-axis and this is your y-axis. There's one point A and there's another point B. So from the origin, there were two lines. The direction will be like this and the direction will be like this. So if I want to find out the position of AB, so that means AO plus OB. This is used to be AO will be what? Negative, right? So AO and positive OB. So we can always have that if OA is there, right? So if OA is there and coming, so we can directly have what? Negative OA. So AB can be written as OB minus OA. So this was the position vector used in what? O levels, where we could always say that CD is OD minus OC, XY is OY minus OX. So these were your vector positions. But now, since we will be working on the 3D figures that will have X, Y, and Z, let's say that A was 2, 4, and minus 8. So we need to write this thing as OA. So this was 2, 4, minus 8. This is in the column form, column vector form. And what does this show? This shows change in X and change in Y and change in Z. Like for suppose this was X and Y. So change in X and change in Y. This was change in X and change in Y. So similar format, let's just say if we want OA 2, 4, negative 8 in 2I plus 4J negative 8K. So this is your Cartesian form. This is your Cartesian form. Similarly, if we have normal coordinate form, so this will be 2, 4, and negative 8. So this is your coordinate form. Coordinate form. That means if we have OA, that is your column format because change in X, change in Y, change in Z. I, J, K will give me the Cartesian form, and normal 2, 4, minus 8 will be your coordinate form. Similar case with OB as well. If we are working with OB, your OB was 2, minus 8, and 16. So your OB was, or B was 2, minus 2, minus 8, and 16. So OB will be minus 2, minus 8, and 16 in this form. Your Cartesian form that we calculated was OB minus. So let's just say that Cartesian form will be minus 2I minus 8J plus 16K, and coordinate form will be minus 2, minus 8, and 16. So this will be your coordinate form for any particular coordinate, your Cartesian form, your column vector form, and the coordinate form. Okay, ji. Now let's just work upon the magnitude of the vector. Magnitude of vector. Since now we are working on the magnitude of the vector, you need to understand that magnitude is the distance between 2 points in a plane. Distance between the 2 points in a plane. Now, the formula that is applied in 2D dimension is under root x square plus y square. But now, since we'll be working on 3D figures, x square, y square plus z square will be the magnitude. So that means if I want to find out the magnitude of AB, or let's just say magnitude of A. Your A coordinate was 2, comma 4, comma minus 8. So I need to have magnitude of OA. So this would be under root 2 square, 4 square plus negative 8 square, which is 4 plus 16 plus 64. So under root 84 will be 2 under root 21, which is 9.17 units. Similarly, if I want to find out magnitude of B, so OB, so B is under root what? B is given as minus 2 minus 8 plus minus 8 plus 16 square. So OB is under root 4 plus 64 plus 256. So magnitude of OB is 18 units. Now this is generally your normal common form. Similarly, since we are talking about the position vector, as I said that position vector is generally in the form of OQ minus OB. So if I want to find out, since we know this is 2, 4, and minus 8, and B is minus 2, minus 8, and 16. And if I need to find AB vector, so this should be OB minus OA. So OB minus 2, minus 8, and 16. Minus OA will be 2, 4, minus 8. So AB vector will be minus 2, minus 2 is minus 4, minus 12, and automatically we'll end up having what? 16 minus plus. So this is 24. So this will be a vector of what? A and B. So generally, if I want to find out the magnitude of AB, this would be minus 4 square plus minus 12 square plus 24 square under root. So AB magnitude will be 16 plus 144 plus 832 under root. So magnitude of AB will be 4 under root 46. So this is your normal way when we are dealing with what? Vectors, and we are dealing with what? Magnitude itself. Okay, so now let's just work upon parallel vectors. If two vectors are parallel to each other, their directional vectors are going to be in same ratio. AB is parallel to CD. That means it will have a constant value. It will have a constant value. Let's say CD, and there is a line that will give me what? AB. So looking at this, let's just say that CD is negative. So this is negative 4, negative 12, and 24. So what we can do is that AB, if you see, is 2 times CD, because if this is minus 2, what we can say is, if this is minus 2, this is minus 4, this is minus 6, this is minus 12, this is 12, and this is 24. So multiply by 2, impact is being there. So AB is minus 4, minus 12, minus 4, minus 12, and 24 is equal to 2 times CD, minus 2, minus 6, and 12. So that means both will end up having the same value, which means AB is 2 times CD. Now, considering that AB is 4 under root 46. So CD magnitude, AB magnitude is 4 under root 46. So CD magnitude will be 2 under root 46. So that means that for parallel vectors, the direction of both vector is same, but the length are different. The length are different. Then what do we have? We have equal vectors. We have equal vectors. Now, equal vectors are very easily understandable. Vector having same length and same direction. Same length, same direction. Two opposite sides of parallelogram are equal vectors. They are equal vectors. So knowing the equal vector is very important. Then what we have is negative vectors. Negative vectors. Now negative vector having exact vector having exactly opposite direction are known as negative vectors. For suppose if I have A and B, and AB is 1, 4, negative 2. So BA will be negative 1, negative 4, and positive 2. That means the direction will change. Since the direction will change, then the signs will change. So that means AB vector is equal to negative BA. AB vector is negative BA. So whenever we have the opposite direction given, we will always change the magnitude sign. So normally your lecture 1 contains position vectors. From position vectors, we worked upon magnitude of vectors. Then we worked upon parallel vectors. Parallel vectors, we worked upon equal vectors and the negative vectors.